scientific evidence is evidence which serves to either support or counter a scientific theory or hypothesis. Such evidence is expected to be empirical evidence and in accordance with scientific method. Standards for scientific evidence vary according to the field of inquiry, but the strength of scientific evidence is generally based on the results of statistical analysis and the strength of scientific controls. Principles of inference: a person's assumptions or beliefs about the relationship between observations and a hypothesis will affect whether that person takes the observations as evidence. These assumptions or beliefs will also affect how a person utilizes the observations as evidence. For example, the Earth's apparent lack of motion may be taken as evidence for a geocentric cosmology. However, after sufficient evidence is presented for heliocentric cosmology and the apparent lack of motion is explained, the initial observation is strongly discounted as evidence. When rational observers have different background beliefs, they may draw different conclusions from the same scientific evidence. For example, Priestley, working with phlogiston theory, explained his observations about the decomposition of mercuric oxide using phlogiston. In contrast, Lavoisier, developing the theory of elements, explained the same observations with reference to oxygen. Note that a causal relationship between the observations and hypothesis does not exist to cause the observation to be taken as evidence, but rather the causal relationship is provided by the person seeking to establish observations as evidence. A more formal method to characterize the effect of background beliefs is Bayesian inference. In Bayesian inference, beliefs are expressed as percentages indicating one's confidence in them. One starts from an initial probability, and then updates that probability using Bayes' theorem after observing evidence. As a result, two independent observers of the same event will rationally arrive at different conclusions if their priors differ. However, if they are allowed to communicate with each other, they will end in agreement. The importance of background beliefs in the determination of what observations are evidence can be illustrated using deductive reasoning, such as syllogisms. If either of the propositions is not accepted as true, the conclusion will not be accepted either. Utility of scientific evidence. Philosophers, such as Karl Popper, have provided influential theories of the scientific method within which scientific evidence plays a central role. In summary, Popper provides that a scientist creatively develops a theory which may be falsified by testing the theory against evidence or known facts. Popper's theory presents an asymmetry in that evidence can prove a theory wrong, by establishing facts that are inconsistent with the theory. In contrast, evidence cannot prove a theory correct because other evidence, yet to be discovered, may exist that is inconsistent with the theory. Philosophic versus scientific views of scientific evidence. The philosophical community has investigated the logical requirements for scientific evidence by examination of the relationship between evidence and hypotheses, in contrast to scientific approaches which focus on the candidate facts and their context. Bechtel, as an example of a scientific approach, provides factors useful for determination of whether observations may be considered scientific evidence. There are a variety of philosophical approaches to decide whether an observation may be considered evidence. Many of these focus on the relationship between the evidence and the hypothesis. Carnap recommends distinguishing such approaches into three categories: classificatory, comparative or quantitative. Akinstein provides a concise presentation by prominent philosophers on evidence, including Carl Hempel, Nelson Goodman, Ubi Braithwaite, Norwood Russell Hanson, Wesley C. Salmon, Clark Gilmore and Rudolf Carnap. Based on the philosophical assumption of the strong Church-Turing universe thesis, a mathematical criterion for evaluation of evidence has been conjectured, with the criterion having a resemblance to the idea of Occam's razor that the simplest comprehensive description of the evidence is most likely correct. It states formally, the ideal principle states that the prior probability associated with the hypothesis should be given by the algorithmic universal probability, and the sum of the log universal probability of the model plus the log of the probability of the data given the model should be minimized. Concept of scientific proof. While the phrase scientific proof is often used in the popular media, many scientists have argued that there is really no such thing. For example, Karl Popper once wrote that in the empirical sciences, which alone can furnish us with information about the world we live in. Proofs do not occur, if we mean by proof an argument which establishes once and forever the truth of a theory, and Satoshi Kanazawa has argued that proofs exist only in mathematics and logic, not in science. See also, anecdotal evidence, scientific evidence, science, scientific method, references.